Hi everyone. Today we'll be talking about Android activity lifecycle. My name is Daniel James and I'm a software developer at Andela. In today's session, we'll be looking at three major things. One, we'll talk briefly about an activity. Then we'll talk about the different states of an application. And finally, we'll talk a little bit about the activity lifecycle. We will look at the different activity lifecycle methods and try to explain them and see how we can make the most of our Android application. So, what is an activity? By now, we all know what an activity is. If you've created one Android project in the past, you must have defined an activity. Simply put, I can say an activity is the backbone of every application, in the sense that an activity holds at a certain time what a user can see in your application. So for example, you're trying to build a login screen for a user in your application. Most often, the activity will hold the user interface that contains all of the view components that is required for a user to log in. So in this case, the activity is going to hold all of the layouts for the username, the password, and the button to sign in. So that means all of your code to display all the user interface for the user login will be displayed on an activity. And all of the controls and all the logic you want to use will be called from the activity. So we can say that an activity is an entry point into a certain feature of our application. Just like in most of our Java applications or Kotlin applications, we have a main function. So the system calls this main function in order for it to run our application. So all of the code, all of our classes, we do the initializations in the main function, and then we're able to run our code from the main function. Therefore, an activity in that case has methods that are defined, which the system calls in order for it to run our application code. Next, we'll look at the different states of an application. An Android application can be said to have 4 different states, or I can say at any given time, the application can be in either of 4 states. 1, it could either be in the foreground. When your application is in the foreground, it is the main activity that the user can see at a certain time. So if, for example, I am playing a game, at that time, the application is in the foreground. So I can see whatever is in the user interface. I can interact with the buttons and continue playing the game. The next state is a paused state or lost focus. There are many factors that could make our applications to be paused. But basically, when another application takes focus of the screen, or when another application is in the foreground, our application will go into a paused state. So in this state, when your application is about to resume, it doesn't have to start all over again. It will call the necessary lifecycle methods in order for it to restore it back to a resume state. The next state is a stop state. When an application is in the stop state, it is no more in the foreground, and the system can easily clear it from the memory. Likewise, when your activity is in the finish state, the system can also clear it in order to have enough memory to carry out other computations. So what is the difference between the stop and the finish state? In the stop state, your application still has or still retains all of the instances or it still retains all of the states of your application. But in both states, the application can be easily killed by the system in order for it to recoup the memory that is being used by your application. So it's necessary for us as application developers to understand these states so that when our application gets into any of the states, we can easily handle some of the scenarios. Next, we'll look at the application lifecycle. Now let's talk about the activity lifecycle methods. Like I said earlier, the activity lifecycle is a set of methods or callbacks in an activity. The system interacts with our application through this callbacks, or we can also use some of these callbacks to communicate with other activities or other applications. From this diagram, we can see two different types of shapes. The first one is the oval shape, and then we have the rectangular shape. The rectangular shape represents lifecycle methods. So from the diagram, you can see there's an onCreate method, onStart method, onResume method, onPause method, onStop method, onDestroy method, onRestart method. Then we have, for the oval shapes, we have the different states, which are represented as activity launched, app process killed, activity shut down, and the other state is activity running. So every activity is launched at some point. Then it enters the foreground, like I said earlier, which is the state where your application is the one running in the foreground and is displayed to the user. And when your activity is finally killed, then it is shut down. Whenever your application or activity is created, the first method is the onCreate method. Usually in this method, we want to do all of our initializations. We want to initialize all our list views, our recycler views, and whatever view we're trying to use in our activity, they're initialized in the onCreate method. So once your activity is launched, the onCreate method is called. After the onCreate, we have the onStart method. Also, we can do a few initializations in that callback. After the onStart, we have the onResume method. Then we have onRestart. And if you look at the diagram, onRestart is called after onStop. So whenever our application is stopped and is about to resume, the onRestart method is called. So in this case, from the onStop method, we're not going back to the onCreate. We will go back and call, the system will call the onStart method of our activity before the activity resumes and comes back to the foreground. So whenever our application is about to go into the background, the first method that is called is the onPause method. So in the onPause method, our activity is no more visible to the user. Then we have onStop, then onDestroy. In onDestroy, the activity or the application is completely destroyed. Whenever we want to start the application again, the application will go through the onCreate method again. So why do we need all of this? If you look at the signature of the method, as it is in the documentation, you will see that each of this method has, most of these methods, or For example, the onCreate method has has a parameter which contains the bundle that contains the states of the application. So if your application is starting for the first time, it doesn't have a state, so there's nothing saved. So in that case, the bundle or the saved instance states will be null. So sometimes we want to check if saved instance state is null before we can carry out initializations. For example, if you're using fragments and you're trying to replace the view with the fragment, you want to check if saved instance state is null or not. If it is not null, you can call the fragment manager, the fragment manager's method, which returns the instance of the fragment by tag, so that you can add it to the view. So in that case, in the onCreate method, you want to check if saved instance state is null. Also, when our application is about to go into the background, it calls the onPause method. Then it comes back to the onResume method. So there are other lifecycle methods that are not in this diagram. For now, we don't need them, but when you're trying to save instance states, for example, when your application is losing focus and leaving the foreground, you want to save some variables or save some states in your application. In that case, we have the onSaved instance state method, where we can take those variables and save them in a bundle. There's a lot we can do there. We're not covering those methods now, but whenever we have the opportunity, we'll look into those methods. Thank you very much for listening.